Okay, Unit 1 review. Finally, I bought a new camera mount. You can't really see it, but I bought it. It's kind of fancy. I'm using my iPhone for this because it's better quality. So hopefully this helps out a little bit. This is just the Unit 1 review. So if you're retaking the Unit 1 test because you bombed it, I'm just going to go through the entire review, like question by question, because it's similar to the test, and then I have specific retakes for that. But you're going to want to watch this video before you do the retake, obviously, because you're retaking it because you bombed it the first time. So make sure you're paying attention. So let's start with number 1. Categorize the following sequences as arithmetic, geometric, or neither. So remember that arithmetic, that's adding or subtracting. Okay, geometric is multiplying or dividing. But remember that we don't divide, what we say is multiplying by a fraction. So for example, if you're dividing by 2, if you see the pattern, you're like, oh, that's dividing by 2. That is the same thing as multiplying by 1/2. So that makes it geometric, and we write it like this, okay? So if it's not adding, subtracting, multiplying, or dividing, it's neither. So looking at this one, we have 1/4, 1/2, 1, 2, 4, 8. So looking at this, you might not be able to see it right away, but we're going to end up multiplying by 2. And the way you can tell, first of all, to check if it's geometric, is take one term and multiply it by the previous term, okay? Or sorry, divide it by the previous term. So this is 8. We're going to divide 8 by 4 on our calculator, and we get 2, okay? So if this is geometric, our pattern should be 2. So then I'm going to do the same thing. I'm going to divide 4 by 2, which I get 2 as well. I'm going to do it one more time just to make sure 2 divided by 1 is 2. Okay, so since the pattern is 2 all the way down, that means that this is geometric. So I'm just going to put a G for geometric. This next one is 75, 72.5, 70, 67.5. So this one, you have a couple different options. So one, it's decreasing. So what I would do is I would just see the difference between 75 to 72.5. So 75 minus 72.5. So I'm subtracting 2.5 to get from here to here. So then if I subtract 2.5 from here, I should get 70 if that's a pattern. So 72.5 minus the 2.5, and you see that that's 70, right? So that means that 2.5 is my pattern, and I'm subtracting that. And subtraction is arithmetic, so we'll call that A, okay? This one, 20, 30, 45, 67.5. So this one's obviously not adding because that would be plus 10, plus 15, plus whatever. So it's not adding, so it can't be or arithmetic. So let's test to see if it's geometric. What you want to do is take the one term and divide it by the previous term. Okay, so we'll do 67.5 divided by 45. And we got 1.5, okay? So what that means is I'm going to take 45 divided by 30, and if I get 1.5, that's my pattern. So 45 divided by 30, I get 1.5, okay? So because I'm dividing and identifying the pattern of 1.5, that makes this geometric. All right, for this one, 12, 32, 52, 72, that's pretty clearly to see that you're adding by 20. Adding is arithmetic. This one, 125, 25, 5, 1. So there's some sort of pattern here dealing with 5s. It's not going to be addition or subtraction because it's a pretty significant drop-off. So we'll take a previous term divided by the term before it. So 1 divided by 5 was 0.2. So 5 divided by 25 is also 0.2. 25 divided by 1 over 25 is 0.2. So we have 0.2 all the way, which means we're multiplying by that, which means this is geometric. All right, and then this one, plus 4, plus 12, plus whatever. So let's see if this is going to be, this is clearly not arithmetic because it's not adding by the same number. So let's see if it's multiplying. So 55 divided by 19 is that. Then we need to see if 19 divided by 7 is the same thing. And you can see that it's not. It's close, but it's not the same exact thing. So this is going to be N for neither. All right, so for number 2, we're going to match the following sequences to their explicit definitions. Okay, so we're going to identify either the first term or the 0 term. So we're going to look for first term or 0 term, and then the pattern. Those are the 3 pieces we need to identify this: the first term, the 0 term, or the pattern. So it's going to be either one of these and then a pattern. Okay, so if you look at this, we have a 0 term. Your 0 term is 2, so that means the sequence starts at 2, and then it goes to 6, and then it goes to 10, and then it goes to 14. All right, so this is this sequence. All right, so we're adding 4 every time, so that's your pattern. So we're going to come over here and look to where we see plus 4. So you only see a plus 4 right here, and you only see a plus 4 right here. So plus 4 is the pattern, okay? The first term is going to be 2. And instead of a first term, it's actually a 0 term. So that means we're looking for just a regular n, not an n minus 1. The n always goes next to your pattern, not next to your first term. So A is going to go right here with 4. 2 plus 4, because plus 4 is my pattern, 2 is my 0 term, times whatever number I'm looking for, okay? So for this one, 2, 4, 8, 16, I'm multiplying by 2, so we're going to come over here and see we have a couple ones that are multiplying by 2, but if you look, it's a 0 term. So a 0 term means that we don't have n minus 1. So B is going to go with 2. Letter C, we have a first term now. So what first term means is that we're going to have an n minus 1 somewhere because the first term, not a 0 term. So my first term is 2, and it goes 2, 4, 6, 8. 2, 4, 6, 8. So that means I'm adding 2. So I'm looking for add 2 here. So I got these options. Okay. Add 2, plus 2, plus 2. Okay. But it's a first term, so I'm looking for n minus 1. This one has an n minus 1, but that's times. This is the only one that's add 2 and then an n minus 1. So this goes with C. Letter D, first term, so I'm looking for n minus 1 again. It's 2, 4, 8, 16, so we're multiplying by 2. That's your pattern. So looking for multiplying by 2, and we're looking for n minus 1 because it's the first term. So this one goes with D. And then down here for letter E, 0 term, 4, 6, 8, 10. We're adding 2 with the 0 term. That's going to be right here. So E is number 1, and the only one left is F. All right, so the main idea is that when you have f of 1, that means you're going to have n minus 1 in your equation. If you have f of 0, it's just going to be n. And these numbers are your sequence. It's your pattern, okay? So for this one, this sequence is 4, 8, 16, 32. So you can see that we're multiplying by 2. That's your pattern. So if you come over here, your first term is 4. Your pattern is 2, and it's to the n power because it's a 0 term, not a first term. All right, for this one, after knee surgery, Veronica's doctor tells her to slowly return to her jogging routine. She suggests jogging for 4 laps a day during the first week, then increasing by 2 laps each week. The graph below shows the progress as she jogs more and more each week. So here's a table. Here's the graph. We need to create a table from the graph. So at week 1, so remember this is weeks because that's the length of time. Time is always your x value. Okay? So this is going to be weeks, and this is going to be laps. Okay, so at week 1, she runs 4 laps. At week 2, she runs 6 laps. At week 3, she runs 8 laps. And at week 4, she runs 10 laps. So that is the table. So here's the graph, here's the table, and then this right here is your sequence. So the sequence is 4, 6, 8, 10. We got that from our tables over here. Okay, so we're going to use this to answer this. So to write a recursive definition, it's always going to be f of n equals f n minus 1. You always start with that. And then you're just going to throw your pattern in, okay? So if you look here, our pattern is clearly add 2, so we're just going to put plus 2, and you're done. The explicit definition, you need your first term, which is 4, times your pattern, which in this case is 2. So actually instead of times, it's going to be plus 2. And then because it's our first term, it's not just n, it's n minus 1, because we're starting at 1. So this is your explicit definition. First term, pattern, subtracting 1, because we're starting at the first term. When it says find f of 10, all you're doing is you're plugging in 10 for the n right here. So it's 4 plus 2 times 10 minus 1. What that represents is how many laps at 10 weeks. Okay, so this becomes 4 plus 18, which is 22. F of 10 is 22. What values of n are appropriate for this context? Anything greater than 0, because you can't have a 0 at 0 weeks. She's not running. You can't have negative because negative weeks don't exist. So anything greater than 0. All right, because in theory, the patient could continue to add laps every week for the rest of her life if she really wanted to. Okay, that's probably not substantial, but that's the idea. Okay, you can't have a 0 week and you can't have negative weeks, so anything greater than 0 would be appropriate. All right, so now for this one. Given the recursive definition, find the explicit definition. So remember, the recursive only gives you your pattern, and you can look here, they give you your initial term. So the explicit definition, you need your first term. So for the explicit definition, you need your initial term and your pattern. That's all you need, and you're just going to write them together. Okay. The kicker here is if it's a first term or a 0 term. So starting here, we have f of 0 equals 3. So I'm just going to write 3 right away because that's my initial term. I'm going to do that all the way down. 6 is my initial term for this one. 27 is my initial term for this one. 3 is my initial term for this one. The reason I know that is from these. So for this one, this says f of 0 is equal to 3. So that means it's a 0 term. Okay, that's going to come in handy in a minute. So then when you look at this, this identifies your pattern. My pattern right here is plus 5, so I'm just going to write plus 5. Pretty simple. I just took the numbers and the pattern and wrote it together. Now you have to put the letter n with it. The n always goes with the pattern, and in this case, it stays as n because it's a 0 term. So if I come down here, I'm going to skip to letter C so you can compare them. 27, my pattern is minus 4, but because this is a first term, instead of n, it's n minus 1. Okay, so same idea, but 0 term stays with n, first term is n minus 1. These ones we have times 2/3 n, because it's a 0 term, and this one is plus 5 times n minus 1. All right, so for this one, examine the following pattern, create a recursive definition, and create an explicit definition. So what we're going to do is we're just going to look at total shapes because there's really not a whole lot of specificity with these. So let's just count total shapes. So we got 4 circles and a square, so that's 5 total shapes. This one is 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9. And this is 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see that my pattern is plus 4 every time. That's going to come in handy. Notice this also says stage 1 and not stage 0. So that's going to mean it's a first term. So for a recursive rule, we have f of n equals f n minus 1. That always stays the same. All you do is put your pattern in. Recursive definitions are the easiest thing to do because this part is always the same. The only thing that changes is the pattern. For an explicit definition, you need your first term. So it's 5 in this case, plus 4, because that's our pattern, with an n. But now it's not just n because we're at stage 1, so it has to be n minus 1. That's your explicit definition. For number 5, the first 2 terms of a sequence are 7 and 21. So find the next 3 terms of his arithmetic. So arithmetic means adding, so that means we're adding 14 to this one. So I believe, I'm going to pull my calculator up because I'm not very smart. 21 plus 14 is 35, plus 14 is 49, plus 14, 63. All right, so if this is an arithmetic sequence and my first two numbers are 7 and 21, that means I have to be adding 14. But if it's geometric, that means we're multiplying. So to get from 7 to 21 through multiplication, I multiply by 3, whereas this one was add 14, okay? So then for this next term, I do 21 times 3. And then that times 3. And then that times 3. And that's where those numbers come from, okay? So they have the same two first terms, but this one's adding 14 and this one's multiplying by 3. For this one, find the next three terms if the sequence was neither. So this could be plus 14, and then we could just do like plus 15. So then this would be 36. And then we could do plus 16, which would be, I don't know, 52. Plus 17, 69. All right, so there's literally no pattern here. We just added 14, adding 15, adding 16, adding 17. There's no consistent pattern because it's not adding by the same thing. All right, so for number 6, finish this arithmetic sequence. So arithmetic tells us that we're adding, and then build the recursive, the explicit, and find M of 6. So we go from 6 to 12 in 1, 2 terms, okay? So what you're gonna do is take the difference, right? We have to be adding. So the difference from 6 to 12 is 6 and divided by 1, 2, 3. Or sorry, divided by 2. So what we're doing here, sorry, let me run that back. So we're gonna take 12, and since we're adding or subtracting, I'm gonna subtract 6. And that gives us a difference of 6. So there's a difference of 6 here in 1, 2 terms. So I'm gonna take that 6 and divide it by the 2 terms. All right, so a difference of 6 to 12 is 6. And I went 1, 2 terms. So 6 divided by 2 is 3. That's my pattern. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. Your recursive definition is f of n minus 1 plus 3. Your explicit definition is 6 plus 3n. And m of 6 would just be 6 plus 3 times 3, which is 15. Oh, sorry. 6. This has to be 6. So it's not 15. It's 24. You plug this in for n. I plugged the pattern in for n. It was a mistake. All right, so once again, arithmetic sequence, table to the right. So 11 minus 2 is 9. That's the difference between here and here. And that difference happened in 1, 2 terms. So 9 divided by 2 is going to give us our pattern. So our pattern is adding 4.5. Okay. So then 2 plus 4.5 is 6.5, plus 4.5 is 11, plus 4.5 is 15.5, and so on, okay? Build the recursive definition. F of n equals f n minus 1 plus 4.5. Build the explicit. First term is 2 plus 4.5, and since we're starting with a 0 term, it's just n. Find p of 12, plug 12 in for n, so it'd be 2 plus 4.5 times 12, and let me see what we get there. $56. Okay. All right, for number 8, this is our last one for the review. Examine the following sequence. So it goes 1,000, 110. Build a recursive definition. So we have to identify the pattern. Clearly this is going down, but by how much we need to find out. So let's do 10 divided by 100 and 100 divided by 1,000, just to make sure that it's the same pattern. Okay, so it's going down by 0.1 or 1/10. Okay. So a recursive definition is f of n equals f n minus 1 times 1/10, Or you could put 0.1. Doesn't matter to me. An explicit definition is 1,000 times 1/10 or 0.1 to the n minus 1. And the reason we do n minus 1 here is we assume this is the first term because they didn't tell us. If they tell you, be specific, but if they don't, you can assume that this is your first term.